So I am really thrilled to introduce today's keynote speaker, who is Wilmot Li from Adobe Research. He's a principal scientist at Adobe Research. He was born and raised in Toronto. It's a shame that we couldn't bring Will home for this conference, but we're really happy that he's able to talk to all of us virtually today. His academic background, he received his bachelor's from Princeton, his PhD from University of Washington. He was a recipient of the Graphics Interface Sweeney Award. We announced the Sweeney Award winners last year. Will won the Sweeney Award in 2004 at Graphics Interface. He's had numerous papers at SIGGRAPH, SIGGRAPH Asia, and CHI and WIST. He's had multiple papers highlighted in the communications of the ACM. This is a big honor. I think Will's research really embodies what we hope graphics interface research looks like. He's cares very deeply about the computer graphics and the interesting math and technology, but also all of his projects really take the human user into account and care deeply about the interaction. So he's studied interactive systems for very complex scenarios. One of my favorites is his work on navigating mechanical objects that have many parts via interactive exploded view diagrams. Recently, I've really enjoyed Will's work on taking face and body capture to drive animation. Will, in general, is just one of my favorite researchers. Anytime I see a new paper come out with Will as an author, I'm just really giddy to read that paper because I know it's going to be really good. So it's a big honor for me to introduce Wilmot Li. So welcome, Will.
Thank you so much, Alec. It's a really nice, slightly embarrassing intro. I'm going to go ahead and share my screen. Hopefully you're seeing that now. Is that true?
Looks great.
Awesome. Okay. Thanks again, Alec, for the really kind introduction. As Alec mentioned, I was born and raised in Toronto. Brought my We the North Raptors shirt just to make that clear, just to prove to you all that's the case. And while it is a bit of a bummer that I'm not able to give this talk in person in my hometown, I'm really excited to be here today. Thank you to all the organizers for inviting me. I wanted to talk today about performance-based 2D animation, which I'll hopefully convince you is a really rich and surprisingly still quite open area for HCI and graphics research. But when I looked at this title, I also realized that it could be maybe a little bit dry for some of you. So I came up with this alternate title that may appeal to those of you who are fans of Stephen Colbert or late night TV. Before I just jump into the content here, a couple of quick logistics. I was originally planning to only take questions at the end just to make things a little bit simpler. But I realized that there's kind of a natural pausing point about partway through where I'd be happy to take some questions maybe over chat if you have questions. And the other really important thing, speaking of the chat, hopefully, please all of you find the chat and bring it up somewhere that's visible, because at a few points throughout my talk, not surprisingly, I'll show some animation results, and I think ideally these should be kind of viewed at a reasonably high frame rate. And so instead of trying to just share them directly over Zoom, what I'll do is I will paste a link, YouTube link, into the chat. And then I'll say, okay, everyone look at the chat. Here's the next video. And then I'll say, click on the link now. And I will actually click on the link at the same time. So what you should see on your side is that video playing at a really nice high frame rate with audio on YouTube for yourself. So have a browser window somewhere. You'll kind of see it also playing. I'll play it as well. So you'll see it kind of being shared over Zoom, but you can kind of ignore that. That's just to make sure that we stay reasonably in sync. I'll stay quiet because there will be audio from your YouTube videos, and then we'll just continue once those videos are done. So just to do a quick test, I'm just going to paste a link now into the chat. I think this should go out to everyone. Okay, so everyone now go ahead and click on this link, and I'll do the same thing.
I'm so angry and out of breath from running up this hill. Oh, I forgot to do the see. I didn't do the eyebrows at the right time. Okay, well, anyway,
Okay, so hopefully that worked for everyone. And hopefully you did not hear the audio from me playing the video on my side. This, I hope, will give you guys all a great experience watching the various videos here. So with that, I'll actually jump into the presentation. Okay, so luckily, or hopefully many of you, or all of you, saw Mira's keynote talk yesterday, where she also gave a brief summary of Adobe Research. Just to kind of recap slightly, we're about 200 members spread over various locations in North America as well as overseas. And one of the things that we really like to do, enjoy doing, is new research that we publish at top HCI and graphics venues. Another thing that we also like to do is to put some of that technology into practice in the form of features inside our products. And this is a couple examples of features that started out as papers and then ended up being high-profile features in Photoshop and Premiere. And this is also really, really rewarding. But in addition to these two main activities, we also sometimes get the chance to work on some bigger initiatives. And today I'm going to talk to you about a project I've been involved with for the past 5 years that falls into this category. And it's definitely been the most fun, satisfying, surprising thing I've worked on in my time at Adobe Research, and I hope you find it interesting too. Okay, so the story begins in 2013 when a couple of us from Adobe Research started chatting with some of the folks who actually originally created Adobe After Effects, which is a widely used video compositing tool. And we realized that we had an opportunity to fundamentally change how people create 2D animation. And that opportunity, in a nutshell, came down to the following goal, which is to make it really, really easy for people to bring static drawings and artwork like this to life, to make it come alive in various ways. Now, of course, this does bear some more explanation because animators have been bringing art to life for decades, really. But the big difference here is that we want to make this much, much easier. And in particular, rather than having artists painstakingly draw every frame or refine keyframes and motion curves, we want to allow users to just perform, to smile, to talk, move their heads around, and for these performances to drive the motion and behavior of 2D characters in real time, as you're seeing here. So you can see the performer in the top right. And this functionality, the program that you're seeing right here, has come together in the form of a new product called Adobe Character Animator, which we first released as a public beta in 2015, and then became an official Adobe product in late 2017. And just one of the perks of kind of being part of this team, part of kind of like the founding group for this team, is that the secret credit screen for Adobe Character Animator includes cartoon versions of all of us, all the contributors. And if you look carefully, you can see me in the bottom right here, looking slightly purple and probably with better hair than I have right now. So that's us, or some of the original folks who worked on Character Animator. And really one of the most exciting things about this effort has been seeing all the incredibly creative things that people have done with Character Animator. For example, in 2016, The Simpsons did a 3-minute segment at the end of one of their shows where Homer, who had joined an improv group, actually answered phone-in questions live from viewers. So you could actually, like, if you put a number up, you could call in, and then you'd be talking to Homer live, and everyone on TV would be seeing him answering these phone calls. And they did the segment using Character Animator, which was really awesome and kind of terrifying all at the same time. And while that was maybe the first big high-profile production created using Character, we were even more excited when we found out The Late Show with Stephen Colbert had started using the product, a really early beta version, without even telling us, to have live cartoon guests on the show, appear on the show. And for those of you who watched Colbert in the lead up to the 2016 election, you probably saw a lot of cartoon Donald Trump and cartoon Hillary. I think there was even a cartoon Bernie at some point. And Stephen Colbert would interview these cartoons live on the show. So just to tell you a little bit more about that, here's a short video describing a bit of how that came to pass. So I'm going to now test this out here. I'm going to paste this link into the chat, and then everyone click on it now.
I had been making complex After Effects puppet rigs at the Colbert Report. From what I read of this new program, Character Animator, it was going to help make that whole workflow easier. So I downloaded it the first day it was out. Everyone had the same reaction.
What am I looking at? Why is it looking back at me and doing what I do? And was just really impressed with the potential of it. What would it take to actually get it on the show? And then it was just kind of a matter of solving that problem we'd given ourselves to make television out of pre-release software.
Well, you remember the old Irish saying?
Oh, sure, lots of old Irish sayings like, if you hit a pig with a stick, you'll be picking splinters out of your bacon.
Well, what if Steven has like an Irish ancestor? That was just sort of the test puppet that we used to kind of like workshop the whole setup.
So Steven sat down and had an unscripted conversation with a cartoon character in real time. Stack's cartoon Irish ancestor was actually making Steven crack up.
Oh, 11 kids, that's wonderful. I had 4 children, and then I had 28 children.
There were still some challenges and hiccups, but when that was happening, it did sort of feel like we were onto something.
Please welcome Cartoon Donald Trump.
I knew that Brian Stack did a great Trump impression, so I built that puppet. The best part of drawing that puppet was making sure I got the hands real small. I like them because they're just dainty, soft hands.
Mr. Cartoon Trump, how do you respond to Anderson Cooper comparing you to a 5-year-old?
Anderson Cooper's a dum-dum. He's a stupid head, a total poopy pants, it's sad.
You could build a scene out of the fact that Steven could show a pen to the cartoon and the cartoon could do that recoil. And we sort of tested it in real time off a laptop in the software, Steven interacting with the software itself for the first time. And that sold it. That was the first Cartoon Trump that night.
No, he didn't.
Yes, he did.
No, he didn't. Infinity.
And so that is when the conversation with Adobe really started running. Producers would come up with ideas. Can Trump do this? Can Trump hold up a sign, put on a Rastafarian hat? And I would say probably, let me try to figure it out. So there were a number of times when I had to talk to Adobe and say, could you write a new bit of code for the program so that we can do this? And the answer was always yes. We're very gracious with working with our schedule, which is often one-day turnaround, if we're lucky.
You know, unless it makes America great again, in which case I started it.
Hillary seemed like a really good second major puppet to unveil, and they wanted Hillary, the cartoon, to be interacting with Steven in real time live for America.
Thank you.
Adobe did this incredibly cool program that pushed the limits of animation, and now we were trying to push the limits of that new program.
High touch of hands, Steven.
That was like a notch in terms of like the growth of how we're using it because it was so ambitious. When it comes to having animation interact with people, I've never seen anything like this. I think we've probably only scratched the surface of what's possible.
Cartoon Donald Trump, everybody. We'll be right back.
Okay, so hopefully you're back with me now, or you're at least near the end of the video. Sorry for the echo with the audio. Originally, I realized that since I'm playing this out of my speakers, that may have been part of the problem. Also, they should autoplay. I think Kelly indicated that it may not be autoplaying for all of you. So sorry if there's a bit of a delay. If it doesn't autoplay, please just click on it when it comes up in your browser. Okay, so I just wanted to say that the experience of us working together with The Late Show and also The Simpsons, as well as a few other productions over the past few years, has been just like incredibly cool. And largely due to the talents and innovations of these content creators, people doing kind of these new kind of live animation kinds of events. We're really fortunate to have been awarded with a technical Emmy this past year for technology and engineering excellence. So just to be clear, these technical Emmys still involve like a nice gold statue, which you see on the right here, but we don't get to show up on the red carpet on TV with actors and other celebrities, which is probably for the best, honestly. Okay, so I will try hard not to turn this talk into a 45-minute ad for Character Animator. Hopefully all of this preamble is whetting your appetite a bit to find out about some of the research and technology around the product. So that's what I'll spend the rest of my time today talking about. But before I do that, I thought this was a good place to kind of pause for a minute and to take any questions over the chat. If you have questions, please go ahead and type, and I'll just take a couple minutes to answer anything that comes up. Okay, I don't see any questions unless I'm missing them somewhere. That's fine too. Feel free to keep them kind of in your back pocket. I will have time at the end for questions as well. So let me go ahead and move on. Okay, so the core paradigm of character animator is something called performance-based animation, which many of you may be familiar with. In character specifically, this takes the form of user-created artwork and binding that to human performances through interactive behaviors. But in general, it's a concept that's been around for really quite some time. And one of the earliest examples is Waldo's C Graphic, a 3D character that appeared on the Jim Henson Hour back in 1989. And he was controlled in real time by, as you can see, a very Muppet-like motion capture device on the top left here. And of course, this type of motion capture has since evolved to be much more sophisticated. And now we see it all over the place in movies and TV. In some ways, it's hard to even call these types of scenes special effects now, given how commonplace they are. And in the world of computer graphics and HCI research, lots of people have explored various ways of enhancing this type of 3D motion capture. And I've just picked two specific examples here. There's many other examples. On the left, we see combining physical simulation with direct motion capture to kind of enhance those motions. And on the right, we see retargeting of the motion of a human actor to 3D characters, in air quotes, with very different types of topologies. There's also mobile apps like Animoji or Facebook and Snap filters that are somewhat similar to the character animator examples I showed earlier, because they also leverage human performances to create real-time animated effects. Now, all of these examples, are really cool forms of performance-based animation. But what I've shown you thus far focuses primarily on controlling 3D characters, where it's possible, at least for the most part, to directly map the performance motion to the motion of the character. So if I turn my head or if I open my mouth, then the character I'm controlling does the same thing. But in 2D, characters are fundamentally different for a few reasons. First, if we leave aside completely hand-drawn animation where the artist creates every frame by drawing, most 2D characters have a really different representation than 3D characters. And specifically, multiple drawings are often used to represent different states of the character. So for example, this Yeti may have one drawing for the front view of its head and then a different one for the profile or 3/4. In most cases, characters who need to talk have different drawings for different mouth shapes or visemes that correspond to different sounds. And if you're familiar with sprite sheets in video games, you may also have seen different discrete drawings for various different poses or different outfits that a character may wear. So in many cases, what we need to do is to now try to map continuous human performances to these discrete representations. Now, a related issue is that 2D characters also don't have complete geometric representations. We don't know what the backs of these characters look like. We don't know their true kind of topologies. If we look at the guy on the left, his eyebrows aren't even connected to the rest of his head. So this is, this kind of incomplete or stylized geometry makes it hard for us to leverage things like physical simulation to enhance human performances with like secondary effects, like let's say we want this cape to wave around or other parts of these characters to kind of jiggle as they move. And finally, another issue that's not directly related to performance, but it does impact the types of techniques we can apply to turn performances into motion, is the fact that 2D animation data is typically pretty expensive to author, and the structure of that data is not very uniform. So in contrast, motion capture data for humanoid 3D characters is usually quite consistent. So as you see here, it's typically a skeleton with joints of the neck, shoulders, elbows, and knees. And that structure is very consistent. But in 2D, animations have much more varied structure. So as we saw earlier, discrete artwork swaps are sometimes used to change the character's pose. In other cases, continuous motion of a skeleton or handles may be used to deform the artwork. And in other situations, frame-by-frame animation may be applied to achieve kind of specific types of effects. So given this range of techniques, there really is not any consistent structure that we can easily extract from 2D animation to use for, say, machine learning. At least it's not easy to extract that structure. So there have been some great previous work that tries to address some of these challenges by proposing various interfaces for directly performing 2D motions. So for example, K-Sketch and Takeo's moving sketch demo as well, which I haven't shown here, they show how direct manipulation and layering of multiple motions can make it much easier to produce many simple animations. In addition, work on fast deformation algorithms also makes it possible to produce natural looking motions by controlling relatively few degrees of freedom. So here we see controlling just a few points with a multi-touch interface to create these animations. And then finally, some early work on 2D facial animation on the right introduced a method for mapping human facial performances to 2D artwork. And this paper on the right is so old that I couldn't even find a video online. I'm sure one exists. It's probably like on a VHS tape in Adam Finkelstein's garage somewhere. But you can kind of imagine how the human actor's performance can drive that drawing, the blue drawing on the right. Okay, so these are just a few kind of early examples of papers that really caught my imagination in this space. But of course, there's been lots of more recent work on making 2D drawings interactive and dynamic, including a really important contribution from Alec and his collaborators on deformation techniques, and also many great papers from folks at Autodesk and U of T and other contributors on dynamic drawings that I don't, unfortunately, have time to describe in detail here, but just suffice to say, we were really inspired by a lot of this work, and we built on top of some of it in an effort to broaden the scope of performance-based 2D animation, both in terms of what types of performance input is possible, and also the quality of the animation output that we produce. And for the remainder of the talk, I'll briefly describe and demo a few related projects that we've been doing towards this end. And then at the end, I'll finish by discussing some future directions that seem really promising. Okay, so to provide a frame, kind of some context for the work that I'll discuss, I'll describe two characteristics of performance-based animation that define what we found to be a key trade-off in these types of methods. So on the x-axis, this represents how easy it is for a user to execute a performance. And I'm kind of being intentionally vague about what I mean by easy. I'll use it to kind of encompass actions that are both easy to learn as well as maybe easy to master. And then on the y-axis, that represents how flexible or expressive the technique is in its ability to produce various kinds of animated results. So how easy is it to express different types of motions or gestures that a character might make. So to make this a bit more concrete, let's put some known techniques onto the list. So I would put raw motion capture, like some of the examples I showed earlier, somewhere over here. If you can just change your facial expression or move your body around and have that drive the character, that's arguably a pretty direct and intuitive interface, or the type of performance. You don't have to learn a new action to have the character open his mouth. You just open your own mouth. But that said, there is a trade-off here in that if the characters you're controlling can only mimic what the human actor can do, that that restricts the things that the character the actions the character can take. Like if you want your character to fly or to turn into a butterfly, as we saw the cartoon Trump do, or have its head explode, you can't express that directly with motion capture, at least hopefully not. So let's look at another point in the space, somewhere over here. I'm calling this discrete input. And this is where you map different buttons or keys on a keyboard or some kind of MIDI device to arbitrary character actions. So as noted earlier, 2D characters often have discrete drawings that represent various poses and gestures that they can perform. So you can assign a discrete trigger to each one of those, and that lets you perform the character. So for example, you may hit one button for the character to scratch its nose, another button for its ears to droop, another button for it to turn into a butterfly. So pretty much whatever you want it to do, you can assign a key to it. And so in this case, it's pretty expressive, right? Like you can, in theory, have your character do pretty much anything. But there is a trade-off, which is that you may end up with like dozens and dozens of different discrete triggers, and somehow you have to control all of that as a performer. Some of those actions may happen simultaneously. So this can quickly kind of devolve into the one-man band problem. You've probably seen these performers with like 10 instruments strapped to themselves, and they're trying to play them all at the same time. Another interesting data point comes from the gaming world, where controllers actually offer a mix of both continuous and discrete input that lets you control a character in real time. And this is, if you think about it, a form of performance-based animation. Now, you can argue a little bit about where exactly I've put this. I think in most cases, game controllers are a little bit more intuitive to learn than just like a random set of discrete input triggers. On the other hand, they may have fewer degrees of freedom than just kind of a whole set of discrete triggers. So maybe it's a little bit lower on the flexibility scale. In any case, I think both discrete input and game controllers are probably a bit harder to learn than just a raw motion capture interface where you're just performing directly. So I'm just going to put one more data point on here because it's really important to almost all character animation, and that is getting a character's mouth to move as if it's saying what the human performer is saying. So convincing lip sync. And this is really critical to the suspension of disbelief for almost all animations. It's also incredibly labor intensive to do by hand. Of course, for live animation settings, we don't even have the option of doing this by hand, right? You can't just have somebody creating lip sync on the fly in real time while somebody's talking. So just like raw motion capture, the performance itself is pretty direct. You're just, talking pretty much. But there's also typically not a huge amount of flexibility. The character ideally will just move its mouth based on the words that the performer is saying. Okay, so overall, what this graph shows is that there are some opportunities about how we can improve performance-based techniques, at least along these two axes. And obviously, the top right of this graph is kind of like a good place for us to be in. And we've been exploring a few different ways to try to get closer to that goal. So the first idea that I'll talk about is to take discrete input, which is very flexible, and make it easier for users to perform. So in particular, the problem we focus on is making it easier to trigger discrete artwork swaps and predefined animation cycles during a live performance. And the approach we've explored thus far is to consider how we can create a triggering interface that automatically adapts to both the specific character, which may have different triggerable poses and actions, and also adapts to the performer, who may execute some common sequences of triggers or actions during performances. So here's a brief explanation and demo of our system. I'm going to go ahead and paste this one into YouTube, so paste this one into the chat. So look for it here, and let's all go ahead and click on that link.
We start with a 2D character represented as a layered hierarchy of parts, some of which have multiple poses. We automatically arrange visual triggers for each pose around the character based on the relative positions of the artwork. We support both row and fan layouts, inspired by feedback from our user study. We implement 3 types of triggers: single selection, causing a single swap; radial selection, with subposes in a radial layout around the trigger; and numerical selection, with subposes associated with the number of fingers pressed in that trigger's vicinity. A key feature of our approach is that we allow users to practice their performances and then leverage those practices to make triggering easier during the live performance. Our system uses every recorded practice to build a Markov model that represents common sequences of triggers. Then, during the performance, our model predicts and highlights the most likely subsequent poses whenever the user
so
hits
hopefully
a trigger.
we're more or less in sync. And so I just want to point out that Nora actually recorded our WISP video using our own system. I don't know if you could tell, but the that
For this
that
performance,
this
our
red furry
participant can either
character was
point to the left,
actually talking with the
point to
narration.
right,
Um,
and then raise
and
your hands in the air.
this is really
As I do
a
that,
pretty simple
notice
idea.
that the next
Rather than
movement
having a
is
fixed kind of
automatic.
undifferentiated triggering interface, let's make it more intelligent and adaptive to the specific setting. There are certainly many other ways to extend or leverage this approach, like building more complex predictive models or ones that try to understand the semantics of natural language. So definitely lots of opportunities to continue pushing in this direction. But for now, let's move on and look at a different way to improve performance-based animation, and that's to try to enhance raw motion capture techniques by making them more flexible and more expressive. So we've looked at a couple of different ways of doing this. The first one gets back to one of the challenges I noted earlier about 2D characters, which is that they have kind of incomplete or stylized geometry. So remember the guy with the disconnected eyebrows. Here, the idea is to try and apply procedural effects to these incomplete 2D representations in order to augment raw motion capture input with really nice secondary effects like dangling earrings, swaying hair, jiggling fat, etc. And so again, let me play a video that will explain this in a little bit more detail and show some of our results. All right, pasting into chat now, and let's all click on it. All right, so I think some of you are saying it's not available in Canada, which is sad. I don't know why that's the case, but hopefully you can see it being shared right now on my screen. Hopefully that doesn't happen for the other videos too. So what you're seeing here, hopefully it's not going to be not as high frame rate, but what you're seeing here is a system that allows us to rig up 2D artwork and to create things like this flowing banner behind the plane, as well as other kinds of effects. So here you'll see like a jiggling type of effect, and it requires a little bit of rigging on the part of the user. So here they're clicking some points that indicate the parts of the ghost that will jiggle and the parts that will be directly controlled by the performer. Oh, thank you for somebody posting a better link for that. Awesome. And so here you're seeing kind of the results of this kind of jiggling behavior. And here we're only controlling the position of the ghost head, more or less. Here's kind of two different variations of that jiggling behavior with loose and tight connections. And one last kind of common type of effect is just to have things bump into each other. But here we can let the user rig up a piece of artwork so that it only collides in certain regions. So here, just the frog's head will push these lilies around, and then the back of the frog is kind of floating underneath the water, or it looks like it's floating underneath the water. Here's just a couple more examples. Since there was a little bit of an issue with the link, I will pause a little bit here and to let folks catch up. Please, if you were watching the link, kind of watching the video with the second link, just type in the chat when you're done, just so I get a chance for, just so I know when most people are done watching it. Awesome. So I'll use Pierre as I'll assume he's a canary, and that many of you are done watching that video now. Okay, so just like with the triggering work, the core idea here is to provide some simple, intuitive rigs that work well with layered 2D artwork, and that combine physical simulation and more procedural effects together. I think this is something that could definitely be expanded further. We just kind of did some initial experiments here. And also it's an idea that earlier work, I should say, by Rubaiyat Habib and colleagues at Autodesk and other contributors explored a bit in their work on motion amplifiers. But in general, it's an interesting problem, how to design the right rigs for 2D versus 3D characters. I should also mention, whoops, sorry, I'm just gonna flip over to back to my slides here. I should also mention that some of these ideas are integrated into character. This is work that was done by, in part by Danny Kaufman and Tim Langlois, also in Adobe Research. And these behaviors show how users can quickly rig characters to create kind of dangling types of effects, as well as to have simple types of rigid body collisions. And these have proven to be really quite popular with users, but their feedback also tells us that making it easier to rig artwork to achieve these types of effects remains a key challenge, and it's one that we continue to push on. Okay, so I said we tried a couple different approaches here for raw motion capture, to enhance raw motion capture. A different approach is to transfer the visual style from example artwork to synthesize a new animation based on the performed motion. And that's what this paper, Toon Synth, is about. So basically, just imagine if we had an artist who could magically draw every frame of animation for a target piece of motion capture, a new target piece of motion capture. That's kind of the goal of this paper. So I will try, I think this link should actually work. Yeah, because it's not an embed link. So before I play the video, just a little bit of setup. The idea here is that the artist first stylizes a source skeletal motion that you'll see in the top by creating hand-drawn animated frames, which you'll see in the bottom. And then from this example, we build what we call a style-aware puppet that encodes the appearance and motion characteristics of the artwork. So now, given a new target skeletal motion, our method will try to automatically transfer the style from the source examples to create and synthesize a new output animation. Okay, so this video actually does not have sound, but I'm going to try pasting it again here, and then I'll go ahead and talk over it. All right, clicking on it now. Hopefully, you guys are seeing it all over the world. Okay, so here we're seeing just the source animation. So the skeletal animation on top and the hand-drawn frames on the bottom. And now we'll show a bunch of different kind of synthesized results with different motion. So here's a kind of like a sneaky walk that's different from the original walk. I think there's some running and jumping later on as well. And so one limitation I'll note here is that the target motions that we transfer this to do have to be kind of similar, somewhat similar to the source motion. So in this case, roughly the same viewpoint. It's like these are all profile animations. I think it would be interesting future work to extend to consider, kind of out of plane rotations. So here's another example from a different point of view with different stylizations. I'll also mention that this method does not work in real time, at least not yet. And so it's restricted to kind of offline workflows. But I think, for me, the promising thing about these results is that it showed us that we can use example-based texture synthesis to kind of expand the expressive range of motion capture and make it possible to create various kinds of hand-drawn looks. Okay, so let's come back to the chart. Just got a couple more quick things to mention here. So far, we've talked about a few ways to enhance the overall motion of animated characters through performance. So I'll finish by talking about one last thing, which is how to drive animation through speech. So this is kind of exemplified by this lip sync kind of dot down here. So in most animations, characters do a lot of talking. Right? So one of the specific instances of this problem that we focused on is to try to make lip sync better. And this work that we've pushed on recently is an effort to do that using machine learning techniques. And just for a bit of context, we worked on an initial implementation of lip sync in Character Animator that shipped with the first few versions that is based on traditional graphical models and some hand-tuned parameters. And it worked pretty well, but there was certainly a lot of room for improvement. It didn't get all the right mouse shapes or Vizians and didn't get the timing perfectly right. So we tried to kind of explore this type of machine learning approach to make improve those results. And in particular, we train a standard recurrent neural network, an LSTM, on hand animated lip sync data. So this is a supervised technique to try to learn the mapping between input speech signals and output lip sync in the form of Vizimes. So I won't go into the details really, but a key part of this effort was figuring out a way to leverage a relatively small amount of hand animated lip sync, which is very expensive to obtain, in order to kind of get these good results. So it's also able to run at a low enough latency to support live applications, which was important for Character Animator. And here I'll play a live capture session that shows the lip sync performing in real time. So I think I'm just going to take this link and then make it unembedded, so that hold on, so that it's like some live editing of this link here. So I think this should work. Hopefully it autoplays as well. So go ahead and click on that link. Oops, that clearly did not work. Hold on 1 second. Okay, I'm just going to quickly try to debug this link for a second here. Okay, here we go. All right, I'm gonna put this into the chat so everyone can click on it. So I hope this one works. Go ahead and click on it now.
This last section of the video shows our lip sync model running in real time in a modified version of Adobe Character Animator. The footage was captured live and the audio was delayed slightly to account for the small latency in the Vizime predictions.
Hello, hello. Check 1, 2. You can see that this is a live capture, so I'm kind of waving my arms right now. The mic is picking up my voice and animating this Chloe character as I talk. So normally we would also enable face tracking to give the performance more life, but here we want you to focus on the lip sync, so we've turned that off. So since this is captured live, the lip sync engine has no knowledge of the script ahead of time. I can literally say whatever I want. Boom shakalaka. Also, I'll point out that my voice was not used in any of the training data for the model.
Hello, I am Shmorgon the Wizard. I'm here to teach you something about compute automated lip sync testing. Check mic 1, 2. Check mic 1, 2.
Okay, so just in the interest of time, I know probably many of you are enjoying my colleague Dan Ramirez speaking like a wizard. I just wanted to, maybe we can just stop that. The session goes on for a bit more, but I think hopefully you get the idea from those first couple of minutes. So I'll switch back to the slides here. One thing I'll just mention is that we also conducted pretty extensive human judgment tests on Mechanical Turk, comparing this new kind of LSTM that we built with the previous version of lip sync in Character, as well as a few competing products. And based in part on that validation, which was pretty positive for the new method, we ended up shipping that new model in Character Animator in late 2018. So that's actually the model that's in the current version of Character if you play with it right now. Yes, Paul, you can do remote teaching as a wizard. We can help set you up with that. Okay, so there's one last thing I want to talk about, one last project I want to talk about briefly. So in addition to lip sync, animators often want talking characters to do other things besides just move their mouths. So for example, camera moves or pose changes or kind of exaggerated emotions. And as we saw earlier in Nora's project on improving triggering interfaces, it can be pretty hard to actually do all that triggering while doing a live performance. And so in this work, Take Tunes, we experimented with an approach that allows users to annotate a script ahead of time with animation events that can then be automatically triggered at performance time when the vocal performer just speaks. So here's just a quick example of that, how that works in our system. So here's a scene in a script where we can annotate the script to specify things like the setting, Jill's studio, as well as the speaker, Jill, who is a red monster, it turns out, and also specific animation events that are embedded in line with the dialogue. So for instance here, this indicates having these little hearts appear above Jill's head, or having this image of Phoenix appear in the background as Jill talks about Phoenix. And there are a few other ones kind of embedded in here as well. But once we have this script and have the scene, now when the voice actor comes in and records the speech, the system can automatically trigger the corresponding animations as she talks. So we're seeing kind of a live teleprompter view here that the performer can see. So as Jill talks, and as it gets to the point where she talks about spring being the favorite season of the year for her, you can see the heart animation gets triggered. She talks about being from Phoenix. The image of Phoenix will show up in the background, and I think there's also some silly fire animation that happens when she talks about how hot the summers are. So this is kind of the basic idea of Take Tunes, is to kind of augment scripts and to use them to make the triggering process easier for performers. Okay, so just to summarize, those are a few of the things that we've been working on recently, and I've kind of labeled them here onto this chart to kind of see where they show up in this landscape. But as you can see, there's more space here in this chart, so that must mean there's opportunities for future work. Couple examples. I think in terms of enhancing raw motion capture, or kind of these types of raw free-form human performances, I think one simple idea would be to kind of detect certain poses or gestures, or maybe even sounds that the user is making during a performance, and use that to kind of auto-trigger some of these types of actions or poses. So kind of combining a little bit of the flexibility of discrete input with the ease of performance for raw motion capture. We could do the same thing for game controllers too. I think that'd be kind of cool to interpret a set of continuous and discrete inputs from a controller to kind of auto-trigger various things. Of course, you can explicitly trigger right now with the game controller, but this might make it possible to kind of make that type of triggering more flexible, and also expand to kind of arbitrary sets of discrete triggers. Another idea with game controllers would be to make the input allow for mistakes, so allow for sloppy input. I think that would be kind of make it easier to perform with something like a game controller. And I think there's also lots of opportunities for speech-based animation as well. So we could try to make it possible to stylize lip sync, or to kind of extend the script-based animation technique that I just showed with Take Tunes, and allow somebody to just, when they just talk with no script, but just based on speech, to add other kinds of animation effects like facial animation, head animation, different poses or gestures. And some folks have explored this a little bit already in the graphics world, and especially for 3D animation, but I think there's lots of opportunities there. And just, as a quick sneak peek, some of my colleagues and external collaborators at Adobe have actually explored a little bit of this notion of speech-based animation. So this is just a quick sneak. I'll leave it anonymous so that we don't get into trouble, but this link, I'll copy here, will just show a couple of really quick results here. So hopefully this one works. Go ahead and click on it now.
Well, of course he will. The Trials of Arabella by Brioni Tallis.
Mummy, you can finally crack open the champagne.
What do you expect me to do? How am I not supposed to get emotional about this?
He doesn't mind a bit that she hasn't a penny. He has more than enough for the two of them.
Okay, hopefully you're back. Just to clarify, for all those results, the input was just a single flat image, which you saw on the left, and then some speech, which created the outputs that you saw on the right-hand side. So this project is actually kind of a good segue. It kind of points at another broad direction for future work, which is to apply modern machine learning methods to cartoon data. That the previous project I just showed does rely on machine learning to produce those outputs. So imagine learning from all of the data that's on the Cartoon Network or Disney cartoons to build better 2D animation tools. Of course, one challenge there, as I mentioned earlier, is that 2D animation kind of has pretty inconsistent or heterogeneous structure. So it's not easy to imagine how exactly we'll learn from all this data. But some recent advances in computer vision have shown us that techniques that work on natural images we can start to adapt them maybe for cartoons, so like the face of art paper, for example. And so maybe that's a way of extracting structure automatically from this type of cartoon data, and to apply maybe less supervised machine learning methods in this setting. And just kind of more generally to finish off here, I feel like performance-based 2D animation is just a really broad and rich area for graphics and HCI research. It cuts across so many classic topics like motion capture and deformation and style-based synthesis and physically based animation, kind of on the graphic side. And on the HCI side, things like sensing, multimodal input, predictive interfaces, and creativity support, just to name a few. So in today's talk, I've shown you a few examples of some of the projects we've been working on in this space. And I hope it convinces you and inspires you to consider looking at this area too. If it does, definitely consider getting in touch with us at Adobe, because we love to collaborate. And for you students out there, there are lots of internship opportunities available as well. And with that, I will just thank visually all the various collaborators here. The external folks are on top, the Adobe folks are on the bottom, including some in cartoon form. And I'm happy to take questions.
You only get to hear the applause from me. Thank you. Thanks very much, Will. That was a really wonderful talk. It was awesome to see all those different works come together. Attendees, please raise your hand in the participants tab if you have a question for Will, or you can type your question in the Q&A tab below, and I'll be looking at that to see if there are any questions. Maybe to get us going, I'll ask one question. So one of the things that amazes me about the character animator software is that it's, like you said, it's bringing together so many different pieces, and it's attacking the problem of performance-driven animation in a way that you seem to be able to aggregate all the different qualities of these works and interfaces without accumulating so much of the flaws. Like each of these methods kind of has their pitfalls or places where they wouldn't work. But somehow it doesn't seem like users are inundated with all those flaws, and they can find the good part. So what's sort of the magic there to avoid accumulating all the flaws of the different methods?
And that's very kind of generous comment. I would say that there are certainly plenty of flaws inside of Character Animator. I think one of the things that we tried to use as like a unifying theme is to retain flexibility, so that artists can always use their own custom artwork and bring that in, and they can perform in different ways, just to try to, like, as much as possible, avoid there being like a specific look or a specific kind of canned type of feel to the output. But honestly, I would say that that is probably one of our biggest limitations right now, which is that there is a lot of character animator output out there that kind of looks a little bit samey, like, because the easiest things to do are just to like bring in one puppet from the frontal view and then just like move your head around. And so that you see a lot of that in terms of the output of character. On the flip side, we're inspired by seeing a lot of the really amazing output that that folks like the Late Show have done, and a couple other productions where they've taken more time to kind of rig up more complex puppets, and then the look starts to be much higher quality. So I do think that is one of the limitations right now, which is that you can achieve really nice looks. We have retained a lot of flexibility, but the process of rigging is still hard, and I think it's harder than we would like it to be. So that's definitely one of the areas that we're pushing on quite a lot.
Great. We do have a question here from the audience. I'll read from Chaitanya. Says, of late, the industry has been moving to physics-based shading and physics-based animation. Do 2D animations also conform to physics-based approaches?
That's a great question. I think they could, and in some sense, the work that I showed on secondary effects, it's trying to like bridge that gap a little bit. Like there's clearly benefits of applying physically based animation, physically based rendering to, I think, many kinds of 2D animation styles, but it's not always easy to understand how to do that because we don't have complete geometric representations. We don't have fully specified like BRDS or other kinds of appearance models typically. And so I think a really interesting open area of research would be to say, how can we help bridge that gap? Maybe we can infer some of those kinds of properties from 2D artwork, or build tools that help 2D artists kind of apply some of those techniques. But I definitely think there's room for that, and I think it could help to really expand the expressive range of looks that we can achieve.
Excellent. So we have a question from Fanny. Fanny, you should be able to unmute yourself.
Yep. Thanks, Will, for a fantastic talk. The way that the artists have to perform the animation is very different from the way traditional animators used to work. Can you comment on like the artistic, components that people felt that might have been removed from them, or what is the different practice?
Yeah, totally. That's a great question. So initially, we were hoping with Character Animator to reach a slightly different audience than traditional animators. If you can draw, if you're an illustrator and you have a character, then we were like, oh, it'd be awesome. We heard some feedback from lots of these users who wanted to tell their stories with animation, but we're not animators. And so we thought that giving them a performance-based tool to take their artwork, their exact artwork, and have it move would be really great. And we did see a lot of that. But then we also saw a lot of animators who wanted to use it because it speeds up their workflows, but then they wanted more control. So we resisted having keyframes in the system for quite some time. And in fact, even now, we don't have a full traditional keyframing-based system inside of Character Animator. But we do support keyframes now because we realize that after you do an initial performance, a lot of animators, traditional animators, want to be able to go in and refine in ways that they're familiar with and they're comfortable with. And so I think there's definitely room for that kind of like blending these techniques. Like I said, we started down that path with Character Animator. You could also just at some point pull in your Character Animator project into After Effects and then get even more control there. So those are some of the options. But yeah, I think it's a good observation. I mean, our hope is that traditional animators find good uses for Character Animator as well.
Thanks.
Any other questions?
I see one in the chat. I can just read it out from Ruben. On a related note to Titania, we also see 3D animation implying looks from 2D animation, for example, Pixar's Spark shorts. Would you see this happen in Character Animator as well? That is a 3D-based representation with a 2D look. That is a really great question as well. We've definitely talked about 3D as a possible route for Character Animator. I think there's a lot of things to recommend that approach. Part of the reason why we haven't gone down that route so far is that there are other 3D tools out there, and there are ways of kind of generating 2D looks with advanced shaders and other kinds of techniques. And so we just didn't feel like it was like a sweet spot for us to prioritize at the beginning, but it's definitely been on our roadmap. We think about the possibilities of 3D quite a lot, and so I think we'll continue considering that. That's part of the reason why we haven't kind of emphasized it thus far.
Excellent. Well, with that, let's thank Will one more time.
Thanks, everyone. Thank you so much. I really appreciate all the feedback in the chat. It's really it's the first time I've done this, so it's really awesome. And apologies for some of the YouTube hiccups along the way, but it looks like in the end we figured out a way forward. So thanks, everyone.
Thanks. I think it worked great. And we'll be back in, let's say, 2 minutes. Let's take a short break for our next speaker.
Awesome. Bye.